So in this video we are going to discuss about determinant. I'll use a single value to represent a matrix, and that I'll say that is my determinant. One more statement comes, that is inverse of a matrix. Just teach the concept, you just grab that concept, understand that, make your notes, and then later on when I start solving the question. Hello students, welcome back to our YouTube channel Geeks for Geeks, GATE, Computer Science and Data Science. So in this video we are going to discuss about determinant. In last two videos we have discussed what is a matrix, order of matrix, transpose, and then we have discussed types of matrices, and then we have solved questions based on that. So in this video we are going to discuss about determinant. So determinant is a unique number which we use to represent a matrix. So how do we find out determinant of a matrix? So first of all, to find out a determinant, a matrix has to be a square matrix. So that means if we have a square matrix, then only we can find out the determinant. So let's suppose the order should be n cross n, right? Then it would be a square matrix. Next thing comes that determinant of order of a matrix 1 cross 1. 1 cross 1, that means this is a matrix A. If I need to find out determinant, I represent determinant with two single lines, right? So here determinant would be this matrix. So determinant of single value would be the same value. Because what is determinant? I'll use a single value to represent a matrix, and that I'll say that is my determinant. So here that is my determinant. Now let's suppose if I'll take any 2 cross 2 matrices, how do I find out determinant of a 2 cross 2 matrices? B is 2 cross 2 and the matrix is A, B, C, D. Let's suppose I need to find out determinant of this matrix. Determinant of this matrix, I'll use two single lines. Here I can represent A, B, C, D. Right? Now, how do I find out this determinant? I'll use cross multiplication. A gets multiplied with D and we'll use a subtraction sign in between. A gets multiplied with D and B gets multiplied with C. So AD minus BC is my determinant. Determinant of a 2 cross 2 matrices. Now if there would be a 3 cross 3 matrix, let's suppose C be a 3 cross 3 matrix, A, B, C, D, E, F, G, H, I. Now you have to understand that how to expand this 3 cross 3 matrices, right? What would we do? If I need to find out determinant of C, that means determinant of A, B, C, D, E, F and G, H, I. Now if I need to find out this determinant, you can use any row or any column. I am using here first row, right? You can use any row or any column and the sign would be alternative. It starts with plus, then negative, then positive. That sign would be alternative. So I'll starting with A, first row. So A is positive. Now when I have written A, now you have to leave that row in which this entry lies and leave that column in which that entry lies. So you are left with A into, you would leave this row and this column, first row and first column. You would left with EF, HI. Then you have minus B sign, because we have minus B, because we'll get to the next entry, the row which we have selected. So now with this B, I'll remove the rows which I have in which B lies and columns in which B lies. So I'll left with D, F, G, I, right? I'll get this determinant, and then later on I'll use C. Now I'll remove the row in which C lies and remove the column in which C lies. So I'll left with, I'm writing it here, C into, what is it? DE, and this is GH. Right? Now you know how to expand 2 cross 2 determinant like this, right? So what would be the determinant? Determinant here, it would be A into EI minus HF minus B into DI minus GF and plus C into DH minus EG. That's how you find out the determinant. 3 cross 3 determinant. If you have a 4 cross 4 matrix, what would you do? You would take any row or any column, expand using into 3 cross 3 determinants, right? Taking one row, 3 cross 3 determinants, and these 3 cross 3 determinants you can find out like this. So that's how you expand the determinant. That's how we find out the determinant. Let's see one question. Okay, we'll see the question later, but before that we have a definition of a singular matrix and a non-singular matrix. A square matrix is said to be singular if the determinant of the matrix is 0. So let's suppose if we have a matrix, let's say we have this matrix 2, 4 and 1, 8. This is a matrix. If I'll find out the determinant here, what would be the determinant? 2 into 4 minus 1 into 8. What would be the determinant here? 8 minus 8. That would be 0. Right? So it is a singular matrix. Singular matrix when determinant is 0, and non-singular matrix when determinant is non-zero. So determinant is important. So one more statement comes, that is inverse of a matrix. Inverse of a matrix. Inverse of a matrix. So you all have heard about it, inverse of a number. What is the inverse of a number? If I have a 2 number, if I'll multiply it with 1 by 2, I'll get 1. So inverse of 2 is 1 by 2. Same we have with this matrix. If I'll multiply A with its inverse, A inverse, I use the matrix A inverse to denote, and I'll get identity. So this A inverse is a inverse of a matrix A. This is basically I'm representing inverse of a matrix. So inverse of a matrix A is A inverse, right? A inverse, and this A inverse exists. A inverse exists only if determinant of A is non-zero. That means if A is a non-singular matrix, then A inverse exists, otherwise A inverse does not exist. Right? So A inverse exists if determinant of A is non-zero. Now I have one homework for you. What you need to do? You just have to see how to find out inverse of a matrix for 2 cross 2, 3 cross 3, till 3 cross 3. Right? So this is the homework. What you have to do here, you need to just go through the concept. I know you guys all know that you have studied at school level. Most of you have, all of you have studied at graduation level, but some of you have remembered, right? So determinant, I made the revision, but for this inverse, just go through all the concept. You have to work on adjoint and cofactor, right? So find inverse. Just how to find out inverse, just go through that, the concept. Right? Just take 3 cross 3 matrix, 1 3 cross 3 matrix, and find out that inverse. Right? But inverse of matrix only exists if determinant of A is non-zero. Now, next thing, what happened? Let's suppose we have some numbers 4, 3, 5, 7, 8, 9, 12, 1, 10. If somebody asks me to find out determinant, I'll go with any row or any column. Right? Let's say I'll expand with this. So I have to work for the determinant. 4 into 8, 9, 1, 10. And then minus 3 into 7, 12, 9, 10. And then plus 5 into 7, 8, 12, 1. So can you see that, how much calculation you need to do to find out a determinant of order 3 cross 3? If it would become a 4 cross 4 determinant, then calculation would become more lengthy. So that means there's lot of calculation required to solve this determinant. So that's why sometimes if we have some of the properties which would be helpful to find out the determinant and make our calculation easy. So these are the properties we are going to study now. Right? So let's go through that one by one. So what it says, first property says that determinant evaluated across any row and any column is same. I already told you that if I'll take any row or any column, it's up to me. I'll take the sign alternative, the determinant would be same. If all the elements of a row are zeros, then the value of determinant is 0. So that means if all the elements of row are zeros, then value of the determinant is 0. Why is that? Because you can see that if we have a matrix in which all the entries are 0, let's say we have this 4, 5, 6. I'll expand using that row. 0 into 2, 3, 5, 6. 0 into 1, 1, 3, 4, 6. 0 into 1, 2, 4, 5. I'll get the whole determinant 0. So if any row or any column is 0, completely 0, I'll expand using that row. I'll get the determinant 0. So determinant using any row or any column. Determinant, if any row is 0 completely or any column is completely 0, then determinant is 0. Determinant of an identity matrix is 1. Right? You can check that by yourself as right? So for an identity matrix, determinant is always 1. Now next we have is determinant of A transpose is equals to determinant of A. If rows and columns of a determinant are interchanged, then the determinant remains unchanged, right? So determinant of A transpose is equals to determinant of A. That means taking a transpose does not make the change on my determinant. The interchange of any two rows or column changes the sign of a determinant without altering its absolute value. What it says, if I'll interchange any two rows or any two columns, then determinant gets multiplied with a negative sign. There is no change in the absolute value of the determinant. What do I mean by that? Let's suppose determinant of the matrix I have here is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a matrix. Let's suppose I am getting the determinant of A as K. I make another matrix B. Let's say I make another matrix B that is 4, 5, 6, 1, 2, 3, 7, 8, 9. Because I have interchanged, then determinant of B would be minus K, because I have interchanged row with column. Let's suppose I'll make another matrix C that would be 6, 3, 9, 5, 2, 8, 4, 1, 7. Now here what I have done, in this matrix I have changed one column. So determinant here is minus K. So minus of minus K would be the determinant. Determinant would be K. So if I'll interchange even number of times, determinant would remain same. If I'll interchange odd number of times, so here I have changed determinant odd number of times, so determinant gets multiplied with minus sign. Even number of times, because negative negative gets positive, so it would becomes positive, right? So interchange of any two rows or columns changes the sign of a determinant without altering its absolute value. Now we have this next property. If two rows in a determinant are identical, then the value is equals to 0. If any two rows or any two columns in a determinant are same, then they have the same, then the determinant is 0. Why is that? Because if you would see here, let's say if I have a matrix 1, 2, 3, 2, 4, 5, 2, 4, 5. You would expand using this. Let's say I am expanding using this 1. Right? If I'll expand using this 1, so I'll have 4, 5, 4, 5. So 4 into 5 minus 4 into 5, that would be gives me 0, minus 2. And first row, first column, 2, 5, 2, 5. Second row, first column. Sorry, first row, second column. Okay? Plus 3. And then 2, 4, 2, 4. So you can see that 4 2s are 8, 2 4s are 8, 0. So you would get always 0 the determinant if you have any two rows are equal or any two columns are equal, right? If any two rows or any two columns are equal, then determinant would be 0. Next thing is, if the elements of a row of a determinant are multiplied by scalar, then the value of new determinant is equals to some scalar times the value of a original determinant. Now what do I mean? This is basically an operation. What operation I am applying? So let's suppose I am multiplying any row with A into Ri, right? I am just element of a row of a determinant are multiplied by scalar, then the value of new determinant is equal to some scalar times the value of original determinant. Let's suppose we have this matrix A, B, C, D. This is my, and determinant here is AD minus BC. And let's say I am multiplying any row or any column. What do I mean? Let's say I am multiplying R2 tends to K into R2. I am just multiplying K with row R2. So A matrix would become AB and KC KD. Right? This is now my A matrix. Now this determinant of A would become K into AD minus BC. And you can check that as well. You would get AKD minus BKC and you can take K common. So if you are multiplying any scalar value in a row or a column, your determinant would also get multiplied with that scalar. Right? If I am multiplying K with this second row and let's say any M scalar in the first row. So I have multiplied with two scalar, k, m with the first row and k with the second row. So your determinants gets multiplied with the scalars k into m, right, from the previous determinant. Okay, so yeah, next we have this property. If b is obtained by adding c times to the row of a to a different row, then determinant of b is equals to determinant of a. What do I mean by that? They are saying that if you apply this kind of operation ri, that means I am changing in row, ith row, I am making a change in ith row, and you are making a change in the ith row with the help of any another row. Let's say I am writing 𝐂𝐤𝐧𝐤𝐬. Are you getting my point? That means I am multiplying scalar, k scalar, with rj, any row, any random row which I have taken, and I am adding it to ri, or I am subtracting. Subtract karna hai, so I'll take k as -1. So if I am applying any kind of this operation, then it would not change my determinant. If I multiply directly a scalar with my row, then that would change my determinant, because we have seen that in the previous property that would make your determinant gets multiplied with that scalar. But this kind of operation, that means I am making a change in ith row, but not directly. I am taking help of any another row rj, and I am multiplying it with k. If you would do ri tends to ri plus k, then that would make a change. You cannot do that. What I am doing, ri, I am making change in row, ith row, with the help of jth row. Or similarly, I can do column wise. It would also not make change in my determinant. These two properties are very helpful, and you would see that these two properties we are going to take it to row reduced echelon form. This would help me to get to basically find out rank and system of linear equation, further many things, right? Basically we are going to discuss these as an elementary transformation, but right now just remember that I am making a change in row, ith row, with the help of jth row. So what, let's suppose this is a matrix 1 2 3 4. What would be the determinant of a here? Let's say this is my a matrix, and I know if I'll find out determinant of a, 4 minus 6 minus 2. Let's say I am just making a change in this matrix. In this matrix A, I am making this kind of a change. What change I am making? I am saying that, let's say I am writing, I am making change in R2. R2 tends to R2 plus 2R1. I am doing that. I am just seeing that it really makes any change or not, right? There might be a possibility that this statement is true or not. I am just checking that. I am just confirming, right? So A would become your 1 2 remains as it is. Let's say I am just making a new matrix B with applying that operation. R2 tends to R2 plus 2R1. Now how to apply that operation? Just take an entry of R2, first entry of R2, 3, and just a minute. Just take this entry of 3, and R2 entry is 3 plus 2 into R1 first entry 1. So 3 plus 2 into 1, that would give me 5, and then 4 plus 2 into 2, that would give me 4 plus 4, 8. So now if you would find out determinant of B, what it would become? 1 into 8 minus 2 into 5. So that means 8 minus 10, that means minus 2. So you can see that determinant does not get changed, and you can just also check by yourself for a 3 cross 3 matrix as well, right? You can check it by yourself. Now next thing we have here is these 3 properties. Determinant of diagonal and triangular matrix are basically product of diagonal entries. So if I'll take a lower triangular matrix or upper triangular matrix or a diagonal matrix, so the determinant would be the product of diagonal entries. And you can just try to expand by a expansion method. You would also get that determinant would be product of diagonal entries. So yeah, product of diagonal entries, and product of diagonal entries, principal diagonal basically. Determinant of inverse of a matrix, if I need to find out determinant of A inverse, that is equals to 1 upon determinant of A. That's why I have said that A inverse does not exist if determinant of A is 0, because then determinant of A inverse does not exist and A inverse does not exist then, right? So determinant of A inverse is equals to 1 upon determinant of A. Next thing is A is an n cross n matrix. Now guys, see one thing, that if you are multiplying K with the matrix A, let's suppose A is this matrix A, B, C, D, E, F, G, H, I. This is your A matrix. And if they ask you to multiply the scalar with this K, so this K scalar gets multiplied with Ka, Kb, Kc, Kd, Ke, Kf, Kg, Kh and Ki, right? So this is a matrix. So now one thing, like you can see here that you have to, like you have multiplied K scalar with first row, with second row, with third row. So that means K gets multiplied 3 times, and we have seen that if we'll multiply any row with a scalar, then the determinant gets multiplied. So let's say determinant of A is A, then determinant of Ka would become here K cube, determinant of A, because K gets multiplied in 3 rows. Right, similar kind of property previous one, but here we have multiplied in the whole matrix instead of multiplying it in the row. So that's why number of rows I have gets cube here to find out determinant of K. Now let's see next thing. Okay, so these are all the properties we have. These are all the properties we have for determinant of a matrix. And now we are going to solve questions based on that. So they are saying that determinant of this matrix is, what would I do? I just need to solve it. We have given a 4 cross 4 matrix. So use that particular row in which we have maximum number of zeros, so that we do not have to expand much, right? Otherwise, if I'll take, let's suppose 8172, I have to expand using this. That would be a problem, na? If I'll take this particular row, let's say I'll take this particular row, 2000, so I'll expand only using this row, this 2 value, because remaining would be 0 into something, 0 into something, so it would not add anything to my determinant. 172 020 061. Now again I need to expand this determinant for the 3 cross 3 determinant, so I'll use this particular column. Why? Again you can see that because it has 2 zeros, so 2 into 1 into this row gets removed, this column gets removed, you would get with 2061. And in this particular row we do not have any non-zero entry, another non-zero entry, so we'll have this determinant. So 2 into 1 into 2, so we'll get the determinant as 4, right? So here the determinant is 4. Now let's see next question. Perform the following operations on the matrix. So we have given a matrix. They are saying that add the third row to the second row, subtract the third column from the first column, and then they are saying that find out the resultant matrix determinant. So we need to find out determinant of a resultant matrix. So what would we do? Should we apply these 2 operations and whatever matrix we are getting, we'll just find out the determinant for that matrix? No, we do not do that. Why? Because you can see here that add third row to the second row. What is this kind of operation? R2, add the third row to the second row. R2 tends to R2 plus R3. That means I had made change in row 2, but the change in row 2 is with the help of R3. I have added R3. Let's suppose R2 is equals to R2 plus 1 into R3. Right? This kind of operation does not make any change on my determinant. We already have seen that it would not impact on my determinant. Now the second one, subtract the third column from the first column. First column में से subtract कर दो third column. Again this is a kind of operation. This is a kind of operation which does not make any impact on my determinant. What are the kinds of operation which does not make any impact? Ri tends to Ri plus KRJ. यही operation लग रहा है पहले वाला. Ci tends to Ci plus KCJ, और K कुछ भी और constant लिख लो. यहाँ पे K1 लिख लिया, यहाँ पे K2 लिख लो. Right? These 2 operations does not make any impact. So whatever be the determinant of this matrix, that would be the determinant of the resultant matrix. That would be the determinant of the resultant matrix. So now one thing you can see here is like only I need to find out determinant for this matrix. Now again I can see that this is a really complex matrix. If I'll try to solve it using my expansion method, it would really get lengthy. So what I have seen that I can take something common out of any column, because if I can multiply any scalar, I can take common as well, na? So if I'll take 15 common from C3 column, what would I get? I'll get, let's first convert this into a determinant. 15 into 3, 4, 7, 8, 13, 2. Keep it as it is. And 15 3s are 45, 15 7s are 105, and 15 into 13 would be 195. You can see that first column and third column is same. If any two columns are same in a matrix, then the determinant would be 0. So here determinant would become 15 into 0. So determinant is 0. Determinant of this matrix is 0. So what would be the determinant of resultant matrix? That would be 0 as well. Right? That would be 0. Determinant here is 0. Now let's see next question. So this is a question, determinant of the matrix is. Again we have given a 4 cross 4 matrix, but one thing I can notice here is it is an upper triangular matrix. So we have seen the property, if we have a upper triangular, lower triangular or diagonal matrix, then the determinant is equals to product of only the diagonal entries. So 6 into, diagonal entries are 6 into 2 into 4 into minus 1. So that would give me minus 48. So option B is correct. Minus 48 is my correct option. This is another question. They are saying that L, M and N be non-singular matrix of order 3. L, M and N be non-singular matrix of order 3 satisfying the equation L square is equals to L inverse, M is equals to L to the power 8, N is equals to L square. Then they are asking for the value of the determinant M minus N. I need to find out determinant of M minus N. This thing I need to find out. Determinant of M minus N. So the question arises that how would I be able to calculate that? So M is equals to L to the power 8. So that means L to the power 8 minus L square. Right? But what would I do here? L to the power 8 minus L square. I am not getting anything from here. Now one thing I have given one more condition, that L square is equals to L inverse. So can I write down, can I multiply L on both sides? L into L square, L into L inverse. If I'll multiply any matrix with this inverse, it would become identity. It would become L cube. So L cube is identity. L cube is identity. Now if I'll solve this L to the power 8, can I write down L to the power 8 is L to the power 3, L to the power 3 into L square? Can I do that? Why I am doing that? Because L to the power 3, L to the power 3 would become identity. Right? I got that. So I'm just simplifying it in a simpler format. Right? So that I'll be able to use it. So L cube I get as identity. L cube I get as identity and it is L square. So L to the power 8 I got as L square, because if I multiply anything with an identity matrix, it remains same. Right? So it would be L square minus L square, and the determinant of a 0, we'll get a 0 matrix, and determinant of a 0 matrix is 0. Right? Which option is true? Option A is true. So these all are GATE previous year questions, all previous year questions. Now one thing you would notice here is that we just have simplified the L to the power 8 to find out the determinant of M minus N. And guys, I am just saying it again, I have mentioned it previously as well, to learn from these videos. When I just teach the concept, you just grab that concept, understand that, make your notes, and then later on when I start solving the question, I am solving the question, I am not giving you time to solve it, so you just pause the video for till that time, try to solve it by yourself, and then go for the solution. Check your solution is correct. If you are not getting it, then just go through the solution key, what I have done here. That is a correct way to learn from these videos. Do not just jump to the solution with me, just try to solve it by yourself, all the questions. That would be very important to learn from these lectures. Okay, now let's see next question. Okay, so this is the next question. it says that given that the determinant of the matrix 130, 264 minus 102 is minus 12, then they're asking determinant of the matrix is 260, 412, 8 and minus 204. How would I solve this determinant? So somebody says like we'll solve this determinant, we'll expand it, but would that be the right way? Would that be the right way? Because we have already given the value. Why would I expand it? So what can I do here? If I'll take 2 common from the second row, you can see that what I'm trying to do here, I am just trying to make this matrix similar to this one, right? So let's say I need to find out 2, 6. What I have given? I have given 1, 1, 3, 0. Or you can do one thing. छोटी सी चीज़ ऐसे ही direct कर लो. This is A matrix and this is B matrix. If one thing you would notice here, what you have given, B is equals to 2A. B is equals to 2A. Every row gets multiplied with 2. 2 1s are 2, 2 3s are 6, 2 4 12 8 minus 2 0 4. Right? B is equals to 2A. Now if I need, and B's are, A and B are 3 cross 3 matrix. Now if I need to find out determinant of B, determinant of B would be 2 to the power 3 determinant of A. Why? Because A is a 3 cross 3 matrix. So we'll get 8 into minus 12. So it would be minus 96. This is one way. Or what you can do to make this determinant 260, 412, 8 minus 204, just try to convert it in this format. 2 I'll take it common from first row, 2 I'll take it from second row, 2 I'll take it from third row. 130, 264 minus 101 minus 102, and I know that this determinant is given to me 12 minus 12. Same thing what we have done here, right? But instead of writing B is equals to 2A, just take out common. अब ये वाली property क्या है? अगर if anything gets multiplied in only 2 rows, also be helpful, right? Here too it is getting multiplied in whole matrix, but sometimes in one row or one column if any scalar gets multiplied, so it would be helpful there. Okay, so minus 12 into 8, that means minus 96. So the determinant would be negative of 96. So guys, that's all we have for the determinant. In the next video we are going to start with rank. Basically first we'll discuss transformation, row reduced format, and then we are going to discuss rank. So that's all for this video. We are going to continue in the next video. But ending this video, before ending this video, I just want to mention that if you have any doubt or any question, just let us know in the comment section. We'll get back to you, or you can find out all the details to joining our channel, Telegram channel, in the description. You can discuss your doubts there as well, and you can also find out the notes of these videos in the link given in description. Okay, so yeah, that's all for this video. Thank you guys. Thank you for joining.